here essentially to tell you guys why is it so hard to do what is it we're trying to do. We're trying to find another Earth. So it's not trying to find life, it's not trying to find those green creatures, it's finding another Earth. So we're trying to find an answer, is there another Earth-like planet? This is not working very well. So why bother? People keep asking me, there's a lot of money putting into this, and some of those answers are up here, but the biggest one is that we are really trying to have another Earth-like planet to compare it to compare the things we know about Earth. So I will be I will be mentioning stars and planets. The only thing I want you to get out of this slide, a star emits light, a planet reflects light. It shows only by reflection. So how are we doing so far? So I actually went on Wikipedia and I put all the planets that we found in other solar systems, and they're all up there in the top left corner. Jupiter is up there, and Earth is in an area there that we have not found any planets yet. Why is it? We heard in the movie we saw, there's a region where it's perfect. Not too cold, not too hot. So this is what we have found so far, and this is what we are actually looking for. And it turns out that it's a difficult problem, but how did we find the other ones, the ones that I showed before? I put up a couple of slides on methods that we're using. One of them is the fact, Newton's third law shows that when there's a planet big enough, the star will move around. So I put in here the top versus this cloud. So we know that when a siren comes to us or moves away from us, it sounds differently. What happens to the sound? Thank you. The other method that we're using is when the planet goes between us and the star, the amount of light that we can detect drops down. And therefore, if we're seeing a periodic drop in that process, in this observation, we know there's a planet there. The problem with an Earth-like planet is that this disk is too small because the Earth is too small. So those are independent. I'm sorry. Hold on. Yeah. I'm in the middle of a talk here. Yeah, I told them about and I'm wearing a sweater. Yeah. Thank you. Thank you. So, sorry about that. The methods that you saw until now, were all indirect. And don't tell the people that are working on it, but we claim that they cannot find Earth. And the reason is that you need to take an image of it. So why is it so hard? If you think of the light that comes to us from the star versus the light that comes to us from the planet, it's like Everest versus 1/100th of a human hair. And the reason that poses a problem is that when light comes in, it's diffracted. It's diffracted by the telescope, and you can see here at the bottom right an image of a star. Now, it's kind of hard to see here with the light here. I simulated what our solar system would look like looking from 30 light years away. This is with the sun. So that is the problem that we're dealing with. What can we do about it? One of the things that we're doing is shape pupils. That is one of the methods that we're using, and if we shape the pupil, you can actually create this dark region where you can find planets. So we are changing the shape of the telescope pupil that the light comes in, and you can see at the top a couple of those pupils and the images that create these dark regions where a planet, if a planet is there, you can actually find it. And does it really work? Actually, this is an image done by my PhD advisor, once with his telescope in the backyard. Another one is when he cut with an X-Acto knife those shaped pupils and put it on the telescope, and you can actually see the other stars, like two stars. What do I do in this project? I actually use a deformable mirror. That's all that I've talked about right now, is all why is it so hard. When you're actually looking, this is not 5 minutes. Was it? There's no way. So what I actually do is adaptive optic thing is that I'm using this deformable mirror, which is a 1 inch by 1 inch mirror that I can deform. There's these 1,000 little sticks under it that you can deform, and I work on the algorithms to decide on the shape to correct for the deformities in those images. Thank you very much.